down, because 220 volt, we don't want that much of voltage, not required. Okay, we need to, suppose you want that much of voltage means your output to DC also will be a high output to DC voltage. But most of the applications, we don't require that much of DC output voltage, not required. So that's what I have mentioned, like you got the application like half wave rectifier, full wave rectifier. It's not necessary to use a transformer, step down action. You need to use only in the case of that center tap full wave rectifier, because in that case, without a center tap transformer, that particular circuit will not work. But in the case of a half wave rectifier, in the case of a bridge rectifier, it's not necessary to use that transformer. So that particular idea has come here already. Hope you have gone through. Okay, I understand you have started studying. Please go through the notes. We have given the different this one, not F. I mean, what is the different installments? We have given the notes. Like first one, I think up to rectifier, then filter, like that you got. And see this particular table. Hope you have gone through. See, you've gone through, and there is this one. See, transformer necessary. No for half wave. No for bridge. Yes for full wave center tap, because now only with center tap only that particular circuit. All right. So that particular idea is already given. Please understand this particular table. This is the what is that? The gist of all this. Now all the important thing. We are making a comparison. And you'll get a fundamental. Well, of course, you can add actually many more properties or parameters. That is up to you. You can make your own short notes or whatever. Okay. So therefore, this will give you some amount of idea. Why I have to say that? See that the ripple factor here. Okay. And see here it's. So these two are better options, when you think about a practical circuit. Because now ripple factor is basically the AC. I mean, it's a ratio of AC to DC. All right. So our target is like when you get a ratio more than 1 means the numerator is more, which means AC is still more. So that is against what we wanted. We wanted to have more DC output than AC. All right. Hope you have gone through these things. I have been repeating like. So therefore, I don't think you will not. They are not a new information. Like, let's go to the next now. So the next information here. Okay, let me check whether. Okay, this is a basic idea already explained. So the basic concept of a filter circuit, that the output of a rectifier is not a pure DC. Therefore, we need to do something again. All right, because AC is still available and still present. And suppose such a circuit, if you're connecting to a sensitive electronic equipment, whichever be the electronic equipment or the gadget you can pick off, that will cause AC harmonics. No, it will cause really, it will damage the circuit actually. It will not produce hum. The hum, like see the echo kind of unwanted thing now will come. Hum and noise. We normally say, you can check now what is the meaning of hum and noise. No, you know it. What is the meaning of it? Noise. Okay, hum, unwanted, that echo related sound will come. Then distortion. Distortion also, like you are, suppose you are giving a sine wave, you will be getting properly, you will not get the output as a sine wave. Instead, it will be a distorted output. It's not a pure sine wave, maybe little of a triangular format or a rectangular format or a square format, etc. Okay. Therefore, you are not getting, because when you have a sine wave, you are sending this one through an amplifier. Amplifier is our next topic. You know that, any small signal, a weak signal can be made strong, very strong signal, very big signal with the help of an amplifier. Amplifier circuit is there everywhere. Amplifier circuit is there. You know it or not, it's there in your gadget. All the gadgets, like it's there. You are enjoying television, you are enjoying music system, you are enjoying your laptop. Everywhere now, because the signal will be weak. We need to strengthen it. So we are doing it now with the help of amplifier. Okay. So if you give a sine wave and you are getting some other format, means distortion happened like that. So if AC is available in the output, okay, in the output, what we call like, it's not a pure DC. So we want to get that pure DC. Therefore, we are making use of this thing in order to eliminate AC harmonics, AC components already available after the rectified output. A filter circuit is used, and that comes between the output and the rectified output. So there the position is, and it will remove. I'm repeating. Okay, last time I took already. I'm just repeating this portion for your convenience, and that can be eliminated. All right. So the AC components can be easily eliminated with the help of a rectifier. All right. So that's what, and we saw this theoretical aspect now, how the capacitor is capable of doing that one. Okay. So this, hope we have gone through the theoretical aspect, how the capacitor, it has got a property. What is basic property of the capacitor? It will allow AC to pass through. It will block DC. So therefore, you are putting this one in a parallel format now. So capacitor filter, we call like shunt capacitor filter. You can check when you check Google and when you check the textbook, you must have come across with that term, shunt capacitor filter. Okay, because capacitor is connecting in parallel format. Serial means it will allow AC to pass through. Again, in the output, AC will be there. But if you connect like this manner, in a parallel format with the load, whatever be the resistance you can think of, like antenna, your loudspeaker, or anything as the resistance, I mean the load, we call like the load resistance. Okay, if you are connecting a motor, motor is the load resistance. Okay, like that. Okay, you've got loudspeaker, you've got antenna, whatever be the last thing. So that's what we call like the load resistance. Okay, so you need to connect this capacitor across that. So after rectification, whatever AC, that will be taken across this one. The capacitor will take care of that action. And last class I already explained. Okay, I've already explained. So therefore you understood that. See, already given. Sorry, I've already given. The notation is not there. It's not there. It's not. So you got it now, like the aspect is already given there. How the capacitor is capable of doing that one. Okay, when the positive half circle is getting charged, then when the other half circle is getting charged, then it will start discharging through the load resistance. By the time the next positive half circle is coming again and charging the capacitor. Okay, therefore you know that one, how this capacitor is never getting time to discharge fully. So therefore you are getting so the output is still not a pure DC, but you are getting much better performance with the help of a capacitor filter. Then those ideas already mentioned in that, you need to go through and try to get that idea. I've given it in the notes also. Then see, this is the kind of circuit now. The other one was with half wave rectifier. Okay. This is with full wave rectifier. There is no change. You can see that. I'll just show here. Hope you are following what I am telling. Okay, let me complete. I'll come back to the doubts part. Okay, see, look at the circuit now. Same connection we are making. But earlier it was a half wave rectifier. Now it's a full wave rectifier. Okay. So therefore, again, all the AC part in the capacitor will take care of. Capacitor will bypass. It's a smoothing circuit. Because capacitor is taking care of that one. All the AC will go through, bypass. You know that, AC will go through the capacitor and DC will be available. Anytime you take capacitor voltage across the plates, now that DC will be available. AC will be allowing. Because now you got 1 by C omega. You know that capacitive reactance. XC is equal to 1 by C omega. C, the capacitance value. Omega, 2 pi F. So you 2 pi F. So as the frequency increases now, so that particular equation will give you the action of the capacitor. Okay. So therefore, I'm not going the details of all that. I have already studied earlier. And look at this one. I got a target now. I just want to go through the next topic also. Because tomorrow I'm taking one extra class just for doubt clearance and other things only. So tomorrow there's a class I'm going to take 12 to 1. I'll send the invitation only for doubt clearance. Okay. So that time all the doubts regarding this one and the examination point of view, what all you have in your mind, how all these PPTs, once again I'll be just showing again. Okay. So therefore you have to, what I want from you people, you please go through the entire notes tomorrow. Just go through once and try to get. Even problems now we'll be taking tomorrow. Okay, 1 hour time is there. It's only for discussion. Okay, it's only for discussion. So certain things, no, you need to, I think you need to read and come. Otherwise, no, you'll be, oh, this is a doubt, that is a doubt, etc. So please read and come. Okay, tomorrow when you come, please go through these notes, go through these problems. So today you spend some time with that. Find some time today before you come tomorrow, no, 12 to 1. Find some time. Then go through all this information. Just go through. Okay, not a very major study because that you may not get time today. But see that, and whichever doubts you come across, please write down in a paper or something. Then you bring that one when we discuss tomorrow. Bring that all those doubts tomorrow, and we will see that. Okay. I think there is a mistake from my side. And Tika already mentioned that that's a DC voltage, not DE voltage or do voltage. Please see that. I think I have corrected that one in the class notes. I've corrected already. Okay, this one before that one. All right. So that part, and I think that's a good thing now, because when you read, you know that one, that this is a mistake in the sense that means you are in the right path. All right. Now, this is another extension I have mentioned in the notes as only for information. In the syllabus, you have only capacitor filter. When you do that one, we never limit our, our knowledge or the information or the study part. Just within our syllabus, we need to go out of that one. Therefore, this information is given. So this information, you can use an inductor also as a filter. Inductor also as a filter. It is possible. But one thing you need to remember, inductors should be connected in series with the circuit. It should be in series with the load resistance. Because the property why it is in series, because that the inductive reactance XL is equal to L omega. Hope you remember the equation you have studied long back in AC fundamentals. Okay, when the inductor depends upon that it will block AC to pass through and it will allow DC to go through. That's a property of that L omega. Omega is 2 pi f. So as frequency increases in our life, the reactance also increases. In capacitor, it's opposite action. So capacitor and inductor, their behavior is just opposite. Okay. So if you want to get DC output in the circuit, see, our target is to get only DC. We are very particular in our goal, right? So if you want to get DC as the output, that you need to connect an inductor in series format. So it is coming in serial format now. So that, okay, DC will be going through and AC is blocked, because AC, that self-induction, mutual induction. Okay, here it's self-induction and the Lenz law opposing all that. You remember all that. Now I'm not going into the details of all that. So that Lenz law is there. It will oppose the change in current, all those things. So it is blocking DC. It is blocking AC. Okay, Faraday's law, all those things are coming over there here. And you are getting, it's allowing DC to pass through. DC means there is no frequency. See, L omega, F is equal to 0. So inductive reactance is 0 for the DC. It's allowing, it's permitting. Okay, so go through that fundamentals, then you will get an idea. Now, so that you are getting, that AC, DC only as the output now, and AC is dropped across this particular circuit. You can take your own value, and depends on the design you can have, and see the output action now. It's already shown there. You have the rectified action also shown, and the filtered output also shown. Of course, filtered output is little less now, because there are mathematical background for that one. And now Lenz law action also coming over there as the AC going up now. You are getting a lower value for the output because of the opposition. Okay, that is obeying. Your Lenz law over that, Faraday's induction, all those things are there. Okay, so this circuit only for information, not for the examination point of view. Now I am showing this slide as well. The reason is this is a practical circuit. This is the practical circuit. All right. So the question now, okay, if you want to get better and almost pure DC, you can really use a combination. Now, why should you limit yourself now with a capacitor or an inductor? Inductor coming in series with the load. Capacitor can be in parallel with the load resistance. So what we can think of, you connect, okay, there is one capacitor. See, this is only for information. I thought I have to share this slide with you, because this is the practical circuit. So after studying all those information or all those details of the inductor, the diode. Suppose somebody, or you are, when you open an adapter, you open a battery illuminator, okay, a battery charger, and you see that, what you studied is a different circuit over there. Naturally, you'll ask me, why, sir, you did not discuss all those things? No, you just limited yourself now within the syllabus. So when you open a battery illuminator, or an adapter, either name, you will find this circuit over there. Two capacitors you will find there. And instead of an inductor, you will find a resistance there. I think, a little rushing last time. And you will find a resistor, because inductors, as I mentioned, it's very difficult. Inductors always create problem. Self-induction, mutual induction, and in integrated circuit, inductors are not there because it takes a lot of space and nobody is interested to manufacture inductor in integrated circuit, etc. So in any circuit, all these coils are coming now. The magnetic field also will come, and there are complications of that. So we'll try to avoid this inductor. Instead, there will be two capacitors. See, two are there. So first capacitor will filter out most of the AC part, and it will go through this inductor. I mean, small value you can think of. Then the second capacitor will definitely, clear out all the remaining AC. If there is any AC present, the capacitor will take care. So when you have this combination, that's why the name, see, pi, the Greek letter, pi. It's in the form of that letter, pi. That pi, So they just gave like a pi filter. Scientists, they always think about the practical aspect, You can easily remember pi filter. You don't have to remember such a big name, like it's a capacitor, then an inductor or a resistance over there, or there is another capacitor. So I think when you think about the structure, etc., their name is very good, like pi filter. It's in the form of a pi, letter pi, and you're getting that one. So you need to think that here across this resistance, you are getting much better DC when you have two capacitor. And you need to remember that this capacitor is of high value, 100 microfarad, even more than that. In bigger ones, we go for 1000 microfarad. So the value of the capacitor is high. Higher the value of capacitor, it will take all the AC coming over there. So you will get better DC. So in all the filter circuits, in our power supplies, etc., we always go for larger value of capacitors so that it will take care of all these AC components available in the rectified output. Okay, this is for information. So practical circuit. Along with that, actually one more resistance will be connecting parallelly, like we call like bleeder resistor. You can put that idea in the Google, BLEEDER. Okay, bleeder resistor, because that is also there in all the power supplies. You check that one. Okay, it's for information. Like that's actually happening in the. So this circuit you will find in most of the power supplies or battery eliminator or adapters. Okay, when you purchase an adapter of 9 volt or 6 volt or 12 volt from the shop, or if you're constructing an adapter or a battery illuminator, this is a circuit we are commonly using. There are two capacitors along with one resistor, so that Now, okay, this part I have discussed already in the other class, which I just thought of spending some time. Along with that, this is again only for information kind. Okay, and we have another resistor. See, diode. We have already studied that Zener diode in detail. There is problem also coming from Zener diode. Theory questions are going to come from Zener diode. Okay, because that is part of our process. What is the process? In order to get a pure DC, you need to do the regulation. So see the action now. First note, step 2, step down. Transformer was there. I think I'll just go back and show that one. That popular diagram. You must have come across already with this. Yeah. See, transformer first now, rectifier, then filter, then regulator. So here you need to have the Zener diode. You need to study Zener diode. And the last one is load. This load can be anything. Suppose you're connecting your laptop is a load. You're connecting a mobile phone, your mobile phone is a load. You're connecting a loudspeaker, no, because loudspeaker now we don't connect directly, because suppose you're connecting an amplifier circuit here, okay, your amplifier circuit is a or you got a power amplifier, so like that. So all those things, this is the last item. Load is the last item. You can think of an antenna over there, because transmitters, TV transmission circuit or radio circuits. Now you have an antenna is the last one. Okay, like that. So it depends upon. So the point is that this whole thing required in order to get a pure DC, and the whole unit you call like a power supply, power supplying unit. Power. See, for any electronic circuit to function, you need to have a power supply. You need to give the power. You want an integrated circuit to function. You see your laptop, you are giving power. You got a charger. Depends upon your configuration, whether it is 9 volt or 12 volt or whatever, your laptop requirement. Okay, or your mobile phone, 5 volt. You need to put the power. Its charging is there. That particular circuit will take care of the power to all the other circuitry inside, whether the processor or all those complicated integrated circuits either inside the laptop or your mobile phone. All those circuits will function only with this power. So that's why we give the name power supply, that there is a power unit. Could be 5 volt, could be 9 volt, could be 12 volt, could be more, okay, 24 volt, etc. Suppose you have a home theater, you have 24 volt power supply requirement will come. Bigger one you have like 48 volt power supplies will come, because then only your remaining circuitry will function. So more power if you want to get like you need to have a more power supply. You cannot think of higher output from like 6 volt transformer and you are using, and the DC output is just 6 volt or 5 volt. You are getting the power less now. Okay, so all those things are information point of view. I don't know whether you are interested in such things. All right, so along with the special semiconductor devices, we had studied in a very detailed way the Zener diode, but this one, you just see this one now, you got that Schottky diode. This you can just go through. I think I'll just allow you people to just go through this slide. It's a semiconductor diode with a low forward drop, voltage drop. You know that, no? Sorry. From silicon, 0.7 drop is there. For germanium, 0.3 drop is there. But now, see the scientists I was just mentioning earlier, you have a variety of diodes are available now. LED, light emitting diodes are there. Then with light emitting diodes, we have 7-segment displays. Varactor diode is there. Tunnel diode is there. Then you have Schottky diode is there. Shockley diode also there. Another one like Shockley diode is there. Then Zener diode is there. So then what else? There are a variety of diodes are available. I mean, it's all how we have difference in the semiconductor material only. The material is different, therefore we get a variety of diodes. So you know very much with respect to this one, LEDs, how different LEDs are giving different colors. So the material we are changing. I've mentioned that one earlier also. Like this is general information. Okay, I'm not going the details of all that because now you are focusing on examination point of view only. So many things. I will limit myself. So Schottky diode is just mentioned in your syllabus. So you need to remember that one side, it's a metal used. So scientists they tried all the possibilities. Why should we go for semiconductor material both sides? Can we use a metal on one side, like any metal you can think of, gold, platinum, or silver, something like. And the other side is a doped material. Okay, doped, silicon used there. And you know that we got a very special diode over there, and it is very fast. It's very fast. And the depletion region, a very small depletion region. So the drop now, it will see when you have depletion region, it takes more time. The reverse recovery time, like that, some word is there. So the silicon diode is taking more time now for switch on, switch off, switch on, switch off, etc. If you don't have a depletion region, this time you can save, like switch on, switch off will be faster. So that's what exactly happening in the case of a Schottky diode. Schottky diodes are very fast. Now when the positive half cycle comes, it's conducting. Negative half cycle. So all those things you can have a faster action now, right? So you have this kind of circuitry is there. This kind of circuitry is there, and all the digital circuit we are making use of Schottky diode. The advantage is that it is conducting very fast. Positive half cycle now, fast now. You can adjust that value in such a way that you can on off will happen very fast. So positive half cycle on, negative half cycle off, again positive half cycle on, negative half cycle off. Like that, it will conduct very fast. So that kind of information, no, you can have it now from a Schottky diode, and it is no from the scientist only. Okay, Schottky is the name of the scientist, like Zener, no, name of scientist only, like Shockley. Okay, he was actually no responsible for inventing that transistor. You know that Barton, Bratton, and Shockley, William Shockley. So Shockley diode also available now. Okay, I'm not deviating. So this part I'm just I have just given this one for the completion of the syllabus, so it can work faster because there is no or very small depletion region, and there is no reverse recovery time over there. No time wasted not during the negative half cycle, etc. Because it can conduct faster, etc. So I ask you people now to get little more information regarding Schottky diode. The reason is it will come in the next semester when we study digital electronics. Next semester topic is digital electronics. There we will study, right? So I just now want you people to get some information and see the symbol used over there. You can see the symbol that S will come. I have mentioned that one earlier. Zener diode Z will come. So how to remember the symbol is easy. Zener diode Z will come. Z. And Schottky diode S is coming. So if you put the other way, it's a symbol of Zener. Okay. So therefore, you need to remember that. They've just put accordingly, like the Schottky means S. Okay, that S is coming our way. So easily you can remember. Now, fine. So I'm slightly moving to the next topic. Yes, I know that you have studied a little bit. I'll spend some 10 minutes only for this one. I just want to introduce. So officially with the Schottky diode, we are completing that particular unit. All right. So I have given except the Schottky diode. I thought okay, it's anyway, right now we are not going to ask any questions. And you can maybe write in your notes Schottky diode. I don't think you require no special notes for that one, because just now for information purpose we will discuss that one. And with that we are completing that particular unit, and we need to start with the second unit. That is 15 hours topic is there actually, the second unit now, and we are getting hardly few days. You know that one. November 25th is the last instruction day for the first years. Okay. Now the next 2 weeks, we'll go for with this mid-semester exam and other things. So hardly we're getting 4 weeks maximum for classes hereafter. So therefore, I need to start this one. Just to start, this is only review part. I know that everyone has already studied this bipolar junction transistor fundamentals. So I'm just revising only. Okay. Of course, this topic is not included for this mid-semester exam. This is not included for the mid-semester exam. So, but let's take what you've studied earlier, maybe in your school days, maybe 7th or 8th or 9th, or maybe in your +1 or +2. Please recollect and just. So deliberately, I have not given the notes. I'll give the notes because even if I give right now, I know that nobody will study because you have to focus on the other chapter only. And please focus that also. Don't focus on this one. But let's revise, like some kind of recap. So transistor. You know that earlier we called like transistor radio because our earlier type of big radios were there. That was with vacuum tube devices. Now it's all transistors are used. Not transistor basically. It's ICs are there right now. Integrated circuit. Okay. So I want to know. Just I'll take a small break or something. Please go through this one now. See, transistor, a 3-terminal device, semiconductor device, with 2 diodes connected back to back in a single piece of semiconductor material. So you can think of a silicon transistor means it's a 3-terminal device, and there are 2 junctions. Okay, and there are 2 types, PNP and NPN. There are 3 regions from which each one there is 1 terminal taken, and you call this one like emitter base collector. See, I want you to know just to go through that. Okay, PNP transistor and NPN transistor. Hope you are with me. Hope you have not switched off and went out or went away from that. Anyway, this is not there for the current exam. So, sir, we got the next week exam, so don't give more information or Now it's not related, so please don't think that way, because I need to start so that at least next weekend, after the exam, I'll get some time, so that, because number of classes now, wow, I'm getting less hereafter. So, but we cannot go so fast, So that, okay, fine. I think yes, you are able to understand this. Can I get some response in the chat? Instead, so, let me see how is the response right now. Let me see this one, whether you have come across already, like a transistor. It's a 3-terminal device. There are no responses in the, whether you have studied transistor. Many of you have not even heard about transistor. Some yes are there, some no's are there. Okay. Don't worry. All the no's, no problem. We will definitely go in detail. I don't know that I got a message earlier also, like some information like transistor portions removed from physics, or I don't know, because the whole area of electronics is with that only, and we are enjoying all the convenience and comfort because of transistor, and the particular topic is not there in the syllabus. Anyway, no problem. We'll have to see that one. Yeah, fine. No issue at all. Okay. Just focus this one. So I'll just this, maybe this also, can you just read, and okay, I'll do some break now. Okay. Sorry. Let's just see that one. This is the information for the present class. This is the last slide I thought of. There are 3 regions. I'll repeat. Hope I'm audible and you are able to read this. 3 regions. Emitter base collector. Middle region is the base. Outer regions are emitter and collector, which cannot be interchanged. You cannot interchange emitter and collector because doping levels are different. Physical size is also different. I don't know whether you have seen a transistor. I have no idea whether you have seen how is a transistor looking like. I'm not sure about that. Okay, anyway, you can't interchange emitter, base, etc. Then base is slightly doped, emitter is heavily doped, collector is moderately doped, because the doping is important now. Like the doping emit electron, because you know that one, it goes from one side to the other end. Through that base, it will cross. So the charge carriers. So the electrons are the charge carriers. You got majority. For PNP transistor, hole. You know that P means holes are the majority. Okay, so that they will cross the junction. So there are 2 junctions. 2 junctions are there, and 2 types of charge carriers are there, and therefore the name bipolar junction transistor. I think you are getting that much of information for the time being. 2 types of charge carriers, 2 junctions are there. And therefore the name, you know that one or something. Okay, the symbol is shown there now with so many things. I don't know. When you look at this, you really get confused or something. I am not sure about that. But you have seen how you can represent a PNP transistor and NPN transistor. So here we are showing equal size. Like you are getting the picture as equal physical size. Actually, they are not. Okay, I'll show another diagram when you come in the next class. Physical construction, like they are not equal. Emitter, see, base is very narrow and very small region, and collector is a large region, so that it can dissipate more amount of heat. You know that especially in power transistors, like you have the heating issues there. I've mentioned that one earlier also. Like the transistor or all the semiconductor devices are like the temperature is a major issue. Temperature, unless you control the temperature, you will have problem, right? So therefore, you need to, the collector region is very large to dissipate that excess amount of heat. Any transistor, silicon especially, forward bias means there is some small amount of heat generation happening. There is a small amount of heat generation because of that exchange, right? Charge carriers are moving across the junction, there is a small exchange. But in the case of LED, you are getting that difference in energy in the form of visible light. Okay, that's a difference. In the case of silicon, it's coming in the form of heat. All right. Now, see that one that I think, see this one. I'll just go back. See, a transistor is a three-terminal semiconductor device with two diodes connected back to back. So that idea is over here now. Are you able to get? I think with this I'll stop. See here, two diodes connected back to back. You can connect now since the diodes are, there are two terminals, one is anode, the other one is cathode. So the connecting back to back now, there are options now, like either you do this format, see the connection is done like this, or you can connect the other way, like no, see positive sides are connected, anodes are connected together, see anodes are connected together, here cathodes are connected together. So naturally you have an NPN version and a PNP version. Okay, see here P, because this side is anode, this is positive side. So anode, then cathode, then anode. See, that's what's shown here. PNP. Here you have N, then P. See, both P, common P, and there is a terminal taken. And N. N is there, no? So NPN. See, this side is N. So that's what technically you have, no? The semiconductor, sorry, back to back. Yeah, they're getting, and accordingly, manufacturing again, or like our semiconductor diode, so many processes are there now, right? Okay, your epitaxial technique, all those details. No, okay, we'll see in the next class now how the manufacturing and how these things are there. So my point is that I just thought of introducing that word, no, transistor for the day. I think I'll have to see now. Okay, now it's already 1 hour 14 minutes, so I need to stop right now. Now I will listen to the queries. I think I will come out of this sharing process now. I think, all right. Okay, now I will listen to. Okay, some of the things I just want to share. I'll stop this one. I want to share. Please listen carefully. The information regarding the mid-semester exam, there are two attachments given. First one regarding the dates of examination. I think you are lucky enough now because you are getting Saturday and Sunday in between. Okay, we are starting on a Thursday examination. We are starting first 2 days. No, you got the languages you have, no? Okay, languages. Then there is a break of 2 days now, 2 days. Then Monday you have, no, Monday, Tuesday, Wednesday. And our exam is on Tuesday. Okay, I think Monday you have physics and other subject now will have computer science. Or common paper will come together. Okay. Then you have maths now later. Okay, ours in electronics paper is on Tuesday, 20th. And please go through the syllabus. I mean, the timetable, don't change that, no? I mean, you need to attend, the exam on that day. If it's a maths exam, you need to go for maths. Don't study electronics and go for mathematics exam. That's the first information I have shared. Second one I have shared yesterday evening regarding the pattern of our paper, electronics paper. Okay, the concerned pattern, you need to contact your respective teachers or HOD. What is your pattern? Please get it in advance so that you can get familiarized with the pattern. You need to understand one very important information that you are writing an examination in your own houses only, in your home, with all your comforts, we are writing the examination. So therefore, now from our side, there are no proctors. We are trusting you people. Please understand. So we are actually testing your sincerity, your integrity, your okay, how you are going to be true to yourself, etc. All those possibilities you can, but we are giving you a kind of assessment of 25%. Actually, you know that it's a question is out of 50, which the system will make it 25%. Mid-semester examination, your entire study, here this one, when you calculate 25% weightage is given. So this is a very serious thing right now. And we are trusting you people. Please refrain yourself from all these malpractices. Though you can actually do it of course, end semester we have the proctoring mechanism. Maybe other departments, they'll go for proctoring. That is up to the department. But we did the same mechanism with your seniors, and they more or less our trust factor is worked there. And nobody got a very high percentage. So what I am trying to tell you is that be true to yourself. though everything is available, because this is an assessment. This is an assessment. So if you do know, as representing the Department of Electronics, I should say that please, you don't have to study, by heart technique, not there now, because this process is different mechanism. Okay. So the questions, simple questions we have included now for the multiple choice. We will give you example, and there will be a mock test also we are conducting. I have already discussed with Hamza madam, and we are in touch with, okay, which manner we can conduct it, so that you will be able to get good marks. Good marks, not like in the sense like 50 out of 50. Suppose now everybody scoring 50 out of 50, then we are really in trouble. Then we are answerable how we have given the question. So either everybody copied or everybody shared all those things, and that will not happen. We know that one. So therefore, the questions, like there are easy questions are there. Very simple questions are there. 25% of the students can easily answer. Or medium range questions are there. 50% of the questions also everybody can answer. Like so. But there are few questions we have included like. Okay, like little complex, so that an average student should not get that answer, because otherwise any question paper, any test, that there is a process, and these are the things followed. We call like Bloom's taxonomy, like how to make a proper question paper, so that 75% of the question, 25 very easy, the next one 50% is medium range, and the last part 25% will be tough. So that that's very few, only smart, very intelligent, or above average students should answer. Otherwise, there is a problem with the question paper. Okay, so please try to understand. We understand your concern. Okay, we will definitely come into your help, etc. But one thing I want like those is examination we are doing. Please do it with all the sincerity and okay. Or I should say that we have that as a Tri-State, we have our core values are there. We have our own ethics are there. Please do that one. Maybe here you will be able to get 45 or 50 out of 50, but I don't think what is finally what you are going to gain, like not much. So therefore, try to refrain from all those shortcuts, all those things. It's not required. If you study definitely, you can score very good mark, even 80% is possible. Okay, so we are trusting you people. Therefore, no proctoring from our side as far as our paper is concerned, and you need to study well. There are questions from problems also. Problems we'll discuss tomorrow. So I listen to all your queries tomorrow. Please go through that. You can write down, etc. That class only for doubt clearance and examination related thing. We will make you comfortable with before the examination starts. It's in the Google platform. Okay, it's in the Google platform only. So what happens, suppose some problem, some power cut or some other thing, or some issue, definitely we will be taking care of. The department will be taking care of, so that nobody will be penalized. You can ask the seniors, and they did very well. That marks, it was very good, in that range only. Like majority of them scored between 60 and 75% range. Okay, so therefore it was a very good way without proctoring, because you are used to that kind of assessment process now. Go some commonplace now, then some invigilation technique, then you are okay monitored, so many things. Now we trust you people, and definitely we have to take few things we have to take care, from the exam. From the examination point of view. Otherwise, if every question is a simple category, then we are in trouble. We can't make an assessment like that. Okay. So we are taking care of all that. So don't worry unnecessarily. Please don't. What is that? Stress yourself. Not required. Any queries, etc. What I understand now, Hamza madam also taking this time now that Thursday's lab sessions. She is taking as a kind of doubt clearance or problem solving kind of thing now. And any queries with respect to examination, etc. You can talk to me or can message me. You need not put it in our group, because in our group other teachers are also there. You want to talk to madam or me, our WhatsApp or email IDs are known to you. You can write to us or message to us, etc. There is no problem. Okay, so don't make, because we have already so many things are there to worry about, in this pandemic time. So examination, definitely we will clear all your doubts and you can definitely do very well. And first years, we are taking it very seriously because you have not seen the college, you have not seen your teachers. So it's totally a different environment. So we understand your worries. Of course, your parents also maybe worried, like, oh, how this is going to happen, etc. But okay, from our side, we'll take care of. And examination related thing, definitely we will take care of, because at the end of the day, it's all about the marks and other things. We are very much aware of that one. All right. All right. So tomorrow I want to see all of you, see that who are all present, who are all wanted to continue in the university in this semester or next semester, etc. Please come tomorrow. Till some absentees I find, I don't know whether they are permanent